everybody. Today I want to just clarify and talk a little bit more about one of our decision analysis examples, because in some cases people may have some problems understanding what's really happening. So although everything in the slide is correct, I thought to maybe put a slightly different spin on it, and maybe it helps people better understand it. If you're happy with the way it is done originally, all good. Just to give you some options for alternative ways to think about it, maybe it helps you. So I want to look at the problem where Annika needs to decide how many iPad minis to order. She has the options between small, medium, and large order size. The demand can be strong, normal, or weak, and you can pause this to more carefully read it. Then I have different profits in thousands that you can make depending on the market conditions and the order size, summarized in the table here. I also typed it up here. Then in a future example that expands on this, she believes that there are different probabilities for the market to be strong, normal, or weak. And we then can say, well, if I have a small order, then I'm going to have different probabilities associated with the profit. So it's sort of like a probability distribution, that in the case of a small order size, the probability excuse me, of making 0.13, the probability of making 1.2 thousand profit is 0.13, and the probability of making 0.8 is 0.53, and so on. And then the expected value just multiplies the profit value, the outcome, with the associated probability, and we get these expected profit values. And then we pick the largest one as the choice that she should make. All right, that's the basic idea. Let's first look at a simple example to illustrate probability trees and Bayes' theorem and all those things that we have something small to build on. Let's suppose we have two urns, the classic probability urn. Urn 1 contains 2 red and 2 blue balls. Urn 2 contains 3 red and 1 blue ball. I am selecting one ball. Let's say here, select one ball. When you think about the decisions you're making, if you are the one standing in front of these two urns with the instruction, select a ball, what are you going to do first? Well, obviously, I'm going to have to put my hand in one of these urns, and that tells me that when I start over here, I can split the possibilities up according to urn 1 or urn 2. And let's suppose it's 50-50, which one I select, right? Then once I have the urn selected, then of course I'm going to end up with a red or a blue ball. But the probabilities are going to be different depending on which urn I select. So doing it in this order makes it possible for me to fill in some probabilities immediately. If it's 2 out of 4 for the red balls in urn 1, 2 out of 4 for the blue balls in urn 1, I have those probabilities immediately. It's given in a way. For urn 2, it's 3 out of 4 and 1 out of 4. And now I can answer a variety of questions. I have it written down here just for convenience for the calculations. Let me show that. So we have our 2 urns. We have 2 red balls and 2 blue balls for a total of 4 in urn 1. Our probability of red from urn 1 will be 2 out of 4. What? What's your problem? You don't like that? Oh, I did something wrong, I think. What do you not like? It's a circular reference. Okay, hold on. Let me just back it up. What's this guy's problem? Oh, I added it up. That's why. Right, I can't do that. Let me fix this real quick. It should just be a comma. There we go. No problem. Excel covered me nicely and told me something was wrong. Okay, thank you, Excel. Next up, for the probability of blue in urn 1, just as we said, it's going to be 2 blue out of a total of 4. Beautiful. And then I can just copy that over here, and we get our 3 out of 4. Copy that over there. We get our 1 out of 4. So I have those probabilities there. If I need to, just use Excel as a calculator, really. Now I can answer a whole bunch of questions, right? Many of the probability questions that I may have are already on the tree. What's the probability of selecting a red ball given you selected urn 1? Well, that's right there, right? So conditional probabilities, some of them are already on the tree, but of course not all of them. A question I could ask is then, what is the probability of selecting a red ball? For example, red. All I have to do with this probability tree is identify which paths give, from start to finish, gives me a red outcome. Well, it's this top one. I can get red via urn 2 or urn 1 or by way of urn 2. If I look at the top path, the probability of that path occurring, the probability of urn 1 and red given urn 1, is simply obtained by multiplying along the path. I'll write it like this because that's how we have our probability, so you can see which one goes where. The probability of the other path is simply obtained by multiplying along the path. Now there's some theory behind what allows me to do that. I don't want to get into that, but let me know if you have any questions. So I have this. Let's calculate it. Well, I can calculate it by Excel, right? I have the numbers over here. It is the probability of the urn is 50-50. 50-50 there. So the probability of red, I'll just do it somewhere, right? Let's do it over here. Probability of red overall, not dependent on the urn, is probability of urn 1 times probability of red given urn 1, just like the tree, plus probability of urn 2 times probability of red given urn 2. Why? Because I'm using Excel as a calculator. The reason is the tree. What did we get? 625. Okay. 0.625. I can do the same for probability of blue. It's this second path, which has probability 0.5 times 2/4. this bottom path as well. They're mutually exclusive, so I can add them together. 0.5, 1 over 4. Let's calculate that just to see what we would get. Let's say over here, probability of a blue. We calculate that. Probability of earn 1 times probability of blue given earn 1. Probability plus probability of earn 2 times probability of blue given earn 2. And as suspected, it is the complement of red, right? Because, let's write it in here just to be complete, 0.375, because red and blue are the only outcomes eventually. So I'm going to get with 100% certainty red or blue. So I could easily get one from the other one, just subtracting it by 1. Okay, that's fair. That is totally fair. Okay. So one thing that I just want to note in this simple situation, I can sort of construct a probability distribution for the color and then the probability of that color, so to speak. And let's put a heading. This is bold for a heading. My colors are red and blue. The probability of red is this 0.625. 62% of the time, 62.5, I will end up with a red ball. And 37.5% of the time, I'll end up with a blue ball. So I have this, let's emphasize here, probability distribution for the color of the balls. Now, I can't do much with this in terms of finding an expected value or something like that because I don't have a numeric variable here. It's just the colors. So this is as far as my little example can go, but we'll soon see that I have a similar situation in the example that we want to discuss. Okay. Now, on the topic of Bayes is really something that doesn't have to be complicated. I have those probabilities. Let's squeeze it in over here. Probability that would require Bayes' theorem or formula or whatever is a conditional probability that's not on here. For example, I can ask, let's paint a picture. Let's suppose I go into a room with this experiment. You're waiting outside. I go into the room, I do the decisions and end up with a ball. Let's suppose I selected a red ball, just for example. I go outside. I have the red ball in my hand. I tell you, I have selected a red ball. It is a fact. What do you think is the probability that it came from urn 1? There is the probability that I'm trying to figure out. Now, this is a conditional probability because you have information that red was selected. But this probability is not on the tree. The tree does not contain all the probabilities. I like a tree that has probabilities that I can easily fill in, but it's not going to have all of them. This guy over here is the probability of selecting red given earn 1. See, I have the opposite situation in terms of how it's presented. This probability here is a conventional probability, just the probability of selecting earn 1. And the fact that I have extra knowledge of it being red may or may not affect the chances of it coming from earn 1, for example. I could change that to earn 2. Let's actually do that. I think that would be the more interesting one. But it could be anything, right? The point is that this probability is not on the tree. Now, if I have a probability like this, that's also not on the tree. You see this 0.625 is nowhere on the tree. It's a conventional probability. It is not a conditional probability. When it's a conventional probability, all I do is identify which paths will get me this requirement. In this case, these two, right? And I add up the probability of each path. The probability of each path I get by multiplying along the path. It's really quite simple. When I have a conditional probability, whether it's on the tree or not, I can use the definition of a conditional probability to rewrite it. Oops, that bracket's not wide enough. To rewrite it into two conventional probabilities. How do I do that? Well, the top is going to be the probability of the intersection, which just means I need both requirements, earn 2 and a red ball. And the bottom probability is going to be the probability of just the given event, or the given requirement, if you will. Now, what's nice is we already have the bottom, but you would have to do this, and that is the bottom. If you haven't done it already, then the whole thing would go in there, okay? So we've done some of it already. The top probability is the probability of conventional probability, not conditional. Earn 2 and red. So I identify the paths that get me earn 2 and red. It's this one. I multiply along the path. There's only one of them. Multiply along the path 0.5 times 3 over 4. It's the only path that can get me both of these requirements. That's the AND requirement, right? Intersection. I need both of them. So let's calculate that. I'll just use Excel as a calculator. 0.5, 3 over 4. Let's do it somewhere randomly up there. 0.5 times 3 over 4. All of that over, I have this 0.625 right there. Go nuts. 0.6. I'm just using Excel as a calculator. I don't need to be fancy with formulas. Let me just make space here, get rid of this line so I can write my answer. 0.6. So you see that originally, if I didn't have any information, selecting an earn is 50%. But it's a little hard to have a good intuition about some conditional probabilities. However, that's why we have a calculation. Because we can't rely on our intuition. This now tells me that if you have information that a red ball was selected, that somehow changes your options, your sample space, and makes it more likely that earn 2 was selected. Now, some intuition is okay here. You can say, well, there are more red balls in earn 2, that if I selected a red ball, it is more likely that it came from earn 2. But how much more likely? 10% more? I didn't know that, right, until I do a calculation. Okay, so the nice thing here is that having a well set up probability tree with probabilities a lot, maybe all of them, all the branches have probabilities on, makes the rest easier in my opinion. Looking at which kind of probability you have to work with. If it's a conventional probability, just identify the paths, add them up. If it's a conditional probability, rewrite it to a couple of conventional probabilities using the definition of conditional probability, and then identify paths again. So this way, I'm using Bayes' theorem, Bayes' formula, without really looking at a fancy, messy formula. By just understanding how to use the tree to answer these probability questions. Okay, so let's keep all of this in mind as we go into our actual question. Now the actual question is going to be, which way up here? I think it's slide 13, right? There we go. There we go. Annika's example with her iPads and the different order sizes and the different market conditions. All right. But when it comes to the decision tree or the probability tree, there is certainly a couple of ways to do this. One way is certainly you have two things that can change. You have the market conditions and you have the order size. So one way is to split it up according to the order size and then split it up again according to the market conditions. But when I look at the probabilities that I have, these in the top here, I have the probability, for example, of the market being strong. Whereas on the tree, that's not any of these branches if I use this tree. This branch up here is the probability that the market is strong given she makes a small order. And to me, intuitively, that feels a little backwards because the market conditions don't depend on her decision. The market is strong, normal, or weak, independent of what she does. So we have the option to alternatively say, I'll write it over here, just get my pen ready, to say this is my start. Let me use a straight line tool. 3 ways I can go to think about what is depending on what, or what is independent. I intuitively want to split things up according to what is independent first. And the market conditions are independent first. So I have strong, normal, or weak. It's not that the previous one is wrong, it's just I'm giving you an option for different ways to visualize this. Now I know she doesn't wait for the market condition to then make a decision. However, the market condition is going to change regardless of what she does. So it feels strange to me, intuitively, to have this tree making it feel as if the market changes after, not necessarily after, but depends, the market condition depends on what she did. But let's continue this diagram. It's just options here, right? It'll eventually lead to the same thing. The benefit, so here I'm not going to write everything in, but she has a small order and a medium order and then a large one. So in general, I like to separate the probability tree from the decision tree. You can argue that her decision-making process flows like this. But when I'm working with probabilities, I can cut it off here. And this is the probability tree over here. And the probabilities are now something I can put into the tree because it is the first split and I know these probabilities. I can put it in. And then maybe other things can happen after that and so on. So I'm just giving you an option that we shouldn't look at this as, oh, this is the only way, I must do it like this. You can flip them around if it feels to make more sense to you. Okay, so that's one thing. So now, if we go much, much further, I didn't cut out all these. Let's just look at, I'm trying to jump ahead here. Okay, so here we go, 31. So now we have an expansion on this example where she can pay for a market survey that will tell her the market is favorable or unfavorable. And then she can base her decisions off of that. So before I want to just think, what do I want to do next? So, okay, let's just read through this. I updated the wording here a little bit to, I think, be more accurate in the information that it is trying to convey. So the market survey is going to say favorable or unfavorable. Okay, and it is not perfect, right? So it can predict favorable 91% of the time if the market is strong. If the market is normal, it'll say favorable 62% of the time, a little closer to 50-50. When the market is weak, then it'll say favorable 28% of the time, which would actually kind of be the wrong decision, right? So you want that to be fairly low. And then we have to figure out, is it worth it for her to use this survey as an extra bit of information in their decision-making process. Now, when I look at the tree that follows, it is quite overwhelming. So my thought could be, there's nothing wrong with this tree. However, what is really happening here? How can I make sense of it if I find this confusing and overwhelming and too much? What's an alternative way to look at this? Okay. So that's what this video is about. So right now, without any survey or anything extra, she expects on average from one period to the next to make a profit of 2.065. That's her expected profit. Let's write it over here, maybe put my pen down. So if she does nothing, originally this is her expected profit. The question then becomes, with the market survey, can she update these probabilities? Because the market survey acts as a prediction that I can use that to more accurately guess what the market conditions are going to be. So essentially what we're doing here is, well, if it says, if I use the market survey and it says favorable, what are these probabilities and how does that affect my expected profit? Right now there's 0 because they're using numbers that aren't there, right? If the market survey says unfavorable, because I don't know which one it's going to say, I need to compare, well, favorable, and I could have an expected result. Unfavorable, it affects these probabilities. It's like an update of these probabilities to be more accurate than her original guess. Using the market survey, I can update these probabilities. However, the survey can say one of two things. That's the problem. So I have two scenarios. In the first scenario, saying favorable, I'm going to get an expected profit. In the second scenario, saying unfavorable, I also have an expected profit. When I combine these two, what is my true expected profit? Okay, so let's map out how this looks based on the fact that they give me some probabilities. Now, what are these probabilities that they give me? This 91 is, if the market is strong, then the report is going to say favorable 91% of the time. So for me personally, if I can have a tree where I can put probabilities on the tree, that's going to be easier for me. And that's always how I've done it. So based on the information, the probability of being favorable is 91% given the market is strong. So the probability tree, it makes sense to have the market condition first, which is independent anyway, and then the favorable outcome. Let's draw that and see what it looks like. Let's go down here. So let's draw. This is my start. Not that you have to write start, but I'm going to put it like this. So there's a difference between the probability tree and the decision tree. Decision tree is sometimes, though not wrong, not convenient for probability calculations because it sort of messes up the information that's being given to me. I can't put it in, and it doesn't always follow a sensible timeline in terms of what depends on what. The market conditions, in my mind, don't depend on anything. So it makes sense to split up according to them first, because I know the market conditions have probabilities 0.13, 0.53, 0.34 in general. But then, if it was a strong market, I'll write it like this, the market survey could say favorable or unfavorable. Favorable, it's going to say with a 91% probability, and therefore unfavorable will be 0.09. If the market was normal, the market survey will still say favorable or unfavorable, but with different probabilities of being correct. In that case, the question says 0.62 and therefore 0.38 for unfavorable. If the market was weak, the market survey will say unfavorable or favorable, favorable with probability 0.28 and therefore unfavorable 0.72. So this is my probability tree, and all these numbers they give me. So it's much nicer to have a tree with all these probabilities on. Now, what am I ultimately trying to find for my purposes of figuring out with the market survey and its two possibilities, what do I expect for the profit, really? I need these probabilities. What are these probabilities? These probabilities are, this one for example, is in words, the probability that the market is strong if the market survey says favorable. The probability that the market condition is normal if the market survey says favorable. And I understand that those are not on this, right? This probability over here is the probability that the market survey is favorable given strong. So what I want, let's say it over here, for example, for the first one, I want the probability of a strong market given a favorable survey result, and that's not on here. And this is where Bayes' formula comes in. All right, let's just see how does Bayes' formula work. Well, if I have a tree like this, it's really quite simple. I wonder if I should maybe put it alongside it. I'm zooming out a touch. There we go. Hopefully you can still read this. I need the space here. So in general, if I have my tree, I can be asked a bunch of probabilities. Some are conventional probabilities that doesn't have given information. Some are conditional probabilities that have given information. First, maybe I'm just going to look at an easier probability that we do also want. Let's just first do that. That was supposed to be an S. First, let's find the probability of the market survey being favorable. Let's just do that. It's an easier one to start with. And we need it anyway, you'll see. So when I have what I call a conventional probability, there's no given information, it's not a conditional probability, it's just a probability. I look at my tree and I say, which paths from start to finish will give me this outcome or this event of favorable? Well, I'll highlight it here, but then I'll erase it because I can't erase it after the fact. These three paths will all lead to a favorable outcome because I don't know what the market condition is. The probability of the top path I can get by simply multiplying the probabilities along the path. Now there is some theory that allows me to do that, And let me know if you want to know that. See, I wrote something and I didn't erase my squiggle. Now I'm stuck. I'm going to have to go all the way back. There we go. So the very top path has probability, the product of the probabilities along the tree, along the path. For this favorable result, it's another option I can get, which is completely separate from the top one. We say mutually exclusive, so we can just add them. The probability of that middle-ish path is 0.53 times 0.62. And the probability of this bottom favorable path is 0.34 times 0.28. So we have to calculate that, but we can easily do that in a second. Oh, maybe we should do it now. And I just realized that I don't have this in Excel very conveniently, but we can quickly do it. Let's do it just on the side here somewhere, right? So we have, let's say here, how should I didn't type this up. We don't have any shortcuts. We have these probabilities up here. Now we're gonna have to just do it. Okay, so we have probability, let's say strong. Let's maybe do it in a row here. Strong, normal, and weak. They have probabilities. I know I'd already have it, but I'll type it in. 0.53 and 0.34. And then we have favorable. Where should I put favorable? Well, I'm just going to do it like this. It doesn't really matter right now. Favorable, and I'll just need favorable. I don't need the rest. Oops, sorry, not there. Move it. Favorable has, if it's strong, the favorable probability is 0.91. If it's weak, it's 0.62. Normal. If it's weak, it is 0.28. So now if we look at the calculation, it's 0.13 times 0.91. It's just these guys together, right? Multiplied 3, 4, and 2, 8. There we go. Okay, so the probability of favorable, I can calculate over here, let's say, as the sum product again, right? If you want to be maybe not a shortcut, you can type it in to see it matches how we match the one we wrote down. That's perfectly fine too. It's not big, so there's no need to get fancy, but a sum product would certainly do it as well. Regardless, there we go, 0.5421. Let's write that in. Okay, so I apologize for that little delay. I'm all tangled up here. What did I just say? 0.5421. Let me just double check. Is that what I said? Yes. Okay, good. All right. Okay. Probability of being favorable versus unfavorable. So here then, for example, the probability of being unfavorable, or not being, the probability of having an unfavorable market survey, well, it's one of the two. It's going to be 1 minus 0.5421 because those are the only two outcomes for the market survey. So I get 0.4579 if I round it like this, which it might be accurate actually. Okay, so I put a line under those two. All right. So let me just map this out. What are we going to do? So if I look back at let's get rid of this. I don't need this anymore. So it's out of sight, out of mind. If I look at my situation, favorable is now going to have a probability of, what did we just say? 0.5421. 5421. And unfavorable will have a probability of 1 minus that. Check that I'm correct. So I'm going to have these two situations with different likelihood, different probability. Okay. Whatever expected profit I'm going to make from a favorable market survey, it'll be happening with a probability of 54%. A little more than most of the time, a little more than 50-50. But there's also a chance it's unfavorable. Whatever profit I can expect to make from unfavorable, I'm going to get that 45-ish% of the time. So now I just want to figure out, okay, what are these profits? I have to do them separately. If it's a favorable market survey, I need to find these probabilities. Okay, so now, all right, so what we need to do is to find these probabilities. That is, if the market survey is favorable, what is the probability of the market being strong? So let's, whoops, not there, over here. Let's write that down. If the market survey is favorable, that's given information, what is the probability of the market condition being strong? And you'll see that that is not a probability that we have on the tree, which is totally fine. All I do then is when I have a conditional probability, I use the definition of a conditional probability, which is the probability of the intersection of all of these, which just means and you should remember this from stats, sorry, that's an ugly line, over the probability of the given information. Let me just erase this little line here. It looks a little weird. I don't need that line. Okay. So that is whenever any conditional probability I can rewrite as a fraction of two conventional probabilities. And the beauty of this is we already have some of this. We have the bottom one. The probability of the market survey being favorable is 0.542. I already have it. The probability of getting the result or event strong and favorable, which paths in my tree will give me that? Only this top one. Only the top one will give me that. Let me just think here. I just realized that my cursor is black, which is not a good idea. How do I do that again? Where's my... I can't remember. I'm just going to go with it. Hopefully you can see where I'm drawing. It's up here. That's the only one. That's the only path that has strong, check, and favorable. Both, right? It's an and. So the probability of that path is 0.13 times 0.19. I calculate that, and I can maybe do that in Excel fairly easy. 0.13, 0.19. We can do it manually. 0.13 times 0.91 rather, divided by the probability of being favorable, which is that one. And I get the market condition is going to be strong if the market survey says favorable. So I need to analyze what do I expect when it's favorable. Well, then I also have to do the same thing for normal. So this would just be updated to normal given favorable, normal and favorable. So here I would just update that to the corresponding path. Normal has probability 5.3, favorable 0.62. I don't want to waste any more time coming up with new formulas in my spreadsheet. Let's just type it in, right? 0.53 times something I don't remember, 0.62, divided by probability of favorable, 60% chance that it's going to be normal. And we have one more. We hopefully see the pattern. Weak and favorable will be this 0.34 and 0.28. 0.34 times 0.28 divided by favorable, which is right there, and I get this. So if the market survey says favorable, let's actually put color on that. Let's go blue. Then I would pick a large order and I would make an expected profit of 4.36-ish thousand, right? Now we simply have to do the same thing for unfavorable, which can sometimes happen with a reasonably large probability. I don't know what the market survey is going to say. I'm going to react differently depending on what it says. So I want to see, well, if it says unfavorable, how am I going to behave? How am I going to decide things? What am I going to do? So I do the same thing, except my condition is when it's unfavorable. All right, so I'm going to erase some stuff here. We can make the cursor bigger, I guess. Nice little eraser here. Very nice. A little wobbly eraser. I like it. Whee! Get out of there. These numbers will change. Like so. Okay. Oops, now my cursor is way too big. There we go, 6-ish. So now, for example, the first one will be, what is the probability of the market being strong if the survey says unfavorable? Well, it's a conditional probability. I can always rewrite a conditional probability as a fraction of two conventional probabilities. The top one is the intersection of all of these, strong and unfavorable, and the bottom one is just the probability of the given condition. Condition, sure. So unfavorable we already have is 0.4579. Strong and unfavorable, you just find which path it is. It is this one. Multiply, whoopsie, no, not that button. Multiply along the path, so 0.13 times 0.09. We can just type it in, or you can make a formula. Does not matter to me. 0.13 times 0.09 divided by unfavorable probability is right there. That's the bottom of my calculation. And I get that if it says unfavorable, there's a very small chance the market will be strong, right? That makes total sense. Then we're going to do the same thing for normal given unfavorable. That is rewritten as normal and unfavorable over unfavorable. So I just update this to be the corresponding path over here, 0.53 and 0.38. So it'll be equal first. 0.53 times 0.38 over unfavorable probability. Yeah, almost 44% of the time. That's fair. And then one more for the bottom path here, doing the same thing, just updating little pieces of it, weak and unfavorable. 0.34, 0.72. 0.34 times 0.72 divided by that. So I can get these probabilities with a very simple tree, just understanding how to use the tree to find different probabilities. If I have a conventional probability, just find the paths that give me that requirement and add them up. If I have a conditional probability, then I simply rewrite it to a couple of conventional probabilities and do the same path finding thing. It's really quite easy. It doesn't have to be fancy. Now, behind the scenes here is Bayes' formula, though I never have to see an ugly formula. There are formulas here. I do have to know some stuff, right? But from your probability class, you should have done this already. So it's easier because I'm drawing on more familiar things than just a formula that I feel very detached to. When I look at this, I don't really understand what is happening here. I don't. Personally, I don't understand. It's not wrong. It is correct. It is just not intuitive for me. So this is an alternative. Now, we're not done. We're almost done. So if the market says unfavorable, market survey says unfavorable, then I'm going to behave differently. And I'm going to behave according to this guy. I'm going to make a medium order because it says unfavorable. It's probably a better decision to not go too large here. I might lose money. So now I just need to merge these two. So now let's think about a distribution, a probability distribution. Let's say this is my distribution. Oops. Let's say I have X as my expected profit and then the probability of X. Okay. What are the possible expected profits? So it's it's a little weird. It's a distribution of expected values. It's okay. First one is this one. And that is going to happen with probability what? It's going to happen whenever the survey says favorable. So it's going to happen with this probability. The other thing that could happen is I could make an expected profit of 1.018-ish. That's going to happen. That's the decision I'm going to make 45% of the time. Whenever it says unfavorable, I'm going to make that decision. So yes, 54% of the time I'm going to get 4.36-ish thousand on average. 45% of the time I'm going to get just over 1. So what am I actually going to get? Well, the expected value of these expected values. It's a little weird. Expected profit when I merge these is, let's put the answer over here. Let's make it green. It's our final result. It's good times. We're almost done. How do I find the expected profit? Let me write it out for you because some people get confused about the sum product and because we don't see which ones are multiplied, right? So let's type it. It's not a lot. The value of X times its corresponding probability plus the next value of X times its corresponding probability. That is the sum product, and you can use the sum product. Maybe do both, see if you can get the same thing. 2.8312. That's what I expect to get because I don't know what the survey is going to say, right? It's a merger of these two, which is a weighted average according to the probabilities. That's exactly what the expected value is. So if I compare this now to doing nothing, oopsie, no, I want to color it. Where's my blue? Was it this blue? Yes. If I do absolutely nothing, screw this survey, not interested. I expect a profit of just over 2. If I take the survey, yeah, sometimes it's going to be low, sometimes it's going to be high, but in the long run, I'll average 2.8 thousand, right? So you look at the difference. Was the price worth it? Just like it discusses in the... Oh, I'm looking for the end here. Where's the end? See, look at all this. Look at all this. Nothing wrong with it. Absolutely nothing. My question is just, do I want to look at this? Or do I want to look at this? Because it's exactly the same. I always prefer understanding what I'm doing instead of just plugging into a formula that I don't really understand. The choice is totally yours. I'm looking for the final answer here. Look at all these calculations. We are already done by the time you do this. 2.8312. Oh, look at that. It's exactly the same. I just took a different path where I understood in more of a broken up stepwise procedure what I was truly doing here. Still get the same answer. So everything is the same here in the terms of the discussion. See how much more do I expect to make? Is it worth paying for the market survey? Well, the market survey only cost 150. I'm making way more than that, right? So on average, of course, but that's all I can really do. Okay. So hopefully this gives you a better understanding. Maybe you like this. Maybe you don't. Maybe you're happy with the way it was done in the slides. There is no wrong answer here. It's just different approaches to arrive at the exact same thing. This is the same answer, right? So hopefully it helps you. Either way, let me know if you have any questions. And that will be the end of this example. Thank you very much.